Good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great event on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, please know you'll be able to access it later on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question. And we'll try to get to as many as we can near the end of today's webinar. Also happening at the end of today's webinar, we'll be doing a drawing for 6 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 6 lucky winners. All right, with that, we'll go ahead and kick off today's webinar, which is how Texas Instruments uses InfluxDB to uphold product standards and to improve efficiencies. Our speaker today is Mike Hinkle, who is the Probe Engineering and Manufacturing Supervisor at Texas Instruments. That is quite a title you got there, Mike. But welcome to the webinar, and I know that you've got a great presentation on tap, so I'm going to go ahead and put myself on mute and let you get right to it.
Okay, thank you. I'll do my best. Thank you everyone for tuning in. So today I'm going to be talking about how I'm using InfluxDB to understand some of our inefficiencies at work. I'm going to here, let me see if I can control this. Okay, so I'll start out just by kind of giving a background to TI. I'm not sure if everyone's familiar with what we do. I know everyone's familiar with the calculators, but we do a lot more than that. Then I'll delve into some of how we use data to make certain decisions, practically all of our decisions, and some of the, how I feel, I guess, to be some of our current shortcomings with our systems. And then finally, I'll go into some of what I'm using or I'm using Influx to model and to look at in time series and specifically. So as she said, if you have any questions, feel free to ask them. I'll try to answer them in the last 15 minutes. So going into it, we've been officially TI since approximately 1951. Before that, we did stuff with petroleum explorations. We're headquartered in Dallas, Texas, which is where I'm located today. We currently have about 30,000 employees. My position is in manufacturing specifically. So we're actually making the wafers and semiconductors and then ship them out to assembly sites or as wafers as a whole. So we have specifically manufacturing sites in the United States and everywhere from Maine to Arizona to Texas. We also have sites in Germany, Japan, and China. So as I said, everyone knows us by our calculators, but we design, manufacture, test, package, and sell semiconductors for all different applications. It could be anything from telecommunications to automotive. So we make a lot. We have a pretty broad portfolio. So as she mentioned, I'm the Probe Engineering and Manufacturing Supervisor. I've been in this position since late September, early October of 2019. My current position, I'm pretty much I do more of people problem solving now as opposed to technical problem solving. I do both, but yeah, my goal is pretty much streamline our operations and to make sure that we're doing it for cheaper, we're doing it faster, and that we're meeting our customer deadlines. Prior to my current role, I was a process and equipment engineer, specifically for LPCVD or low pressure chemical vapor deposition reactors. I was over the phosphorus reactors where we would actually deposit P2O5 or phosphorus pentoxide to make our semiconductors electrically active. I would also do TEOS, which is tetraethyl orthosilicate. So I was actually depositing material on the semiconductors for, say, a capacitor dielectric. So that's what I did previously, and like I said, currently I'm actually more of a human role and efficiency role. So I'll get into that more. I want to cover some of our common terms that we use at work, just because some of them will come up in how I'm using Influx and how I'm using Grafana. But so what you're seeing to the right is what we're producing. Now this is actually 150 millimeter wafer, so it's an older technology. Newer technologies are using 300 millimeter, and reason being is that you get more bang for your buck. Your yields are higher. You actually have more ICs that you can fit onto a wafer form. But we actually, we still run some 150 millimeters. So what you're seeing is actually a picture off of our site. Now, when we do we call it a lot start. So a lot start is just saying, hey, we have wafers that can comprise up to 25 wafers for a lot, and I believe that's pretty standard across the industry. Now we could have a lot with 12, wafers in it. It just depends on what the customer demand on and what we're starting at the time. But typically, on average, we have 25 wafers in a lot, and then we actually produce we get the silicon, we do all of our processes, we hand it off to test probe and then multi-probe. So the division I'm in, the group I'm in now, we actually test the semiconductors after they come off the manufacturing floor. And where I was at before, we call it front end of the line. So we were actually making the transistors and everything that are on the ICs. So I'll say tool a lot because a lot of the metrics that I'm capturing revolve around tool. When I say tool, I'm not talking about a DeWalt drill or Makita. I'm talking about something like these furnaces, which you see to the right. So these are some of the old phosphorus process that I actually owned, is what we call it. But they're horizontal furnaces in this case. Most of the newer furnaces are actually vertical because we have a less variability in the process. But some of the other tools that we're actually looking at metrics on have furnaces, ion implanters, epi reactors, plasma etchers, metrology. The list just goes on and on. Now I also use state because we capture a lot of our what's happening on the floor using states. Now when I say state, we're referring to whatever the tool state it's currently in or was in the past. Now we use that oftentimes to say, hey, we're going to perform a PM or preventative maintenance on a tool. So if I'm going back through and I'm binning out failures or looking to how I'm spending my time or my tool's spending my time, then I'm typically looking at the states I'm in. Now it gets kind of confusing. We have currently, and this is dynamic, 515 different states within my building that we use across all the different modules to track what a tool is doing at a specific time. I listed a few, obviously prods production, this 06Ts for tube change for diffusion, 01, that's pretty standardized across all modules. It has to do with a hard down for a tool. So we had an electrical or a mechanical failure on a tool or an issue with the pump for a low pressure process, and then it might go into 01. It just depends. It gets kind of messy and it's hard to track, and part of the time series database and part of what I'm doing is trying to show those bins so everyone can understand them, because even seasoned engineers that we've had for 30 years don't necessarily know how a state's counted or what metrics it goes against or what things actually mean, and they always change. So modules, I've said this a few times already. So it's just kind of a common division of processes and tools that we have. So our implant people are with implant, diffusions with diffusion, test is with test, probes with probe. So most of our meetings and everything are spent trying to fix our specific module problems. And we have a lot of cross-team meetings and everything, but most of the times we're meeting and troubleshooting stuff, we're doing it with our own teams. And that's divided by our modules. Now we report out very often, which I also said. So our reports typically end up being, preparing days for a presentation to explain why my tools weren't performing how they were supposed to and what I plan to do to fix that. Now, some of the metrics that we get graded on or that we track a lot from a higher level are our tool availability. Analogous for that, for the group I'm in now, is overall equipment utilization. It's pretty much the amount of, it's the ratio of how much time I'm testing good die versus my total time that tool's up. We look at raw fail events, and also we have that normalized depending on how many wafers you actually can move through a tool. Some of the diffusion processes, which I keep speaking to because I'm familiar with, a lot slower process. Now we run batches of up to 100, 200 wafers, so you get a lot more throughput, but at the same time you could be running a 12-hour process or a 8-hour process in a 1,000-degree furnace. We also look at mean time to repair and mean time between our failures. First pass success has to do with our quals. So if I have to perform a PM on a tool, and afterwards I obviously need to make sure that I didn't do anything to shift where we're normally performing, or didn't induce a failure. So we also look at, hey, did I pass or fail my qual right after I was done with my PM? So stuff like this we actually look at. Cycle time's important. I pay a lot more attention to that now, since I'm kind of straddling the fence between engineering and manufacturing. But yeah, obviously we want to be able to meet our customers' demands. We want to be able to meet deadlines. And yeah, so go on a little bit. So our data, we make every decision pretty much based on data. So we've been around for a long time. We have databases, mostly relational, that you have to pretty much swim through to try to piece together whatever decision you need to make. Now, some of the day-to-day, obviously, process adjustments. Some of this is automated now, and we have some advanced process control, but if something happens, we always have to go back and try to figure out, what have I looked like recently? How have I been, say, depping material over the last month? After I did the PM, did it shift? If I'm out of control, how do I bring it back in control? Also, we look at our CPK, which is process capability. We have some say so in our upper and lower control limit. Our ultimate goal is to try to narrow our window on where our process is running. Our spec limits are set by our device and our customers' needs and applications. I've also mentioned some of these other ones, the tool stability, AO, OEU, mean time to repair, mean time between failure. I mentioned these because these are all pretty much temporal data, and a lot of this we're expected to answer to a lot, and we wear a lot of hats and we have a lot of responsibilities, and not all of us have 30 hours a week to prepare for presentations. So some of the spirit of using some of these time series database and some of this tooling is to be able to have some ready-made data to either take it into meetings for preparation, or in the case I'm using some of my stuff for, it's a real time to know what's happening. So if there's a real time issue on the floor that's systemic or catastrophic, that we're able to respond in a timely manner. And we are a 24-hour operation. We operate 365 days a year. We don't have time off for Christmas. Well, I mean, you can take time off for Christmas, but there's always someone working. Lights are always on in the building. So it's important that we're able to see what's going on and be able to respond to it effectively, whether it's 2 in the morning or it's 7 o'clock in the morning on a Monday. But we also use our data for troubleshooting. Obviously, we look at tool comments, we look at what states we've been through, how long we were in them, how long did it take to respond to a down, how long did it take to get it back up, all these small signals. So yeah, we do this now. Obviously, we have finance groups that look at our planning, look at how much money we can earmark for the next quarter. We try to do look aheads in the group I'm at for our planning to see, well, do I have the proper tester types that I need? Do I have enough of them? Is my hardware ready for when after that month passes and the semiconductors make it through the fabs? Will I be able to handle the testing, or will it end up being a bottleneck? So these are all different things that we have to look at on a pretty frequent basis. any of the inaccurate or misrepresented data or misinterpreted data that we get, well, any of this stuff as far as process adjustments, if I make a poor process adjustments based on some inaccurate data, I can scrap 100 wafers in the blink of an eye, which equates to, in some cases, over $100,000. So it's important that we have access to that data. And a lot of times it's hard with our older systems, and not everyone's a data scientist, not everyone's a DBA and able to access it themselves. So those of us that have an interest in it may not be professionals at it, but more hobbyists, we try to interject that where we can to try to make all the engineers' life easier. Some of our current challenges, let me see. We obviously, like I already spoke to, we need immediate feedback if something's happening, because it could be catastrophic. We can miss customer deadline, we could scrap hundreds of thousands of dollars of material, and obviously we'd be discussing that in meeting rooms for quite a while after if that happens. So the ability to get email notifications or text notifications or any of that stuff and to be able to automate, it's very powerful. Now, as far as I've already mentioned the meetings a little bit. So we do have a lot of meetings, and in fact, I would argue we probably have too many. I think I've had over 25 hours of meetings in 1 week, and I wasn't even a manager. So to be able to work on top of that and get your job done, you end up putting in 70 or 80 hours a week, and not to mention looking for the proper data. So part of this effort and part of this, the spirit of this whole thing is to try to automate as much of that as possible to be able to actually go out and attack real process issues or go out and attack real cost savings measures, and be able to leave the reporting, make it as automated as possible so everyone it can be all hands on deck, and we can just strive to be a better company and actually solve those really interesting problems. But I liked this stack that I'm going to go into a little further, mainly because a lot of the people I work with, they're physicists, they're mechanical engineers, they're electrical engineers. And I can honestly say that in my building, we have no full stack developers or data scientists. Now, we do have groups that are devoted to that, but they're not in our group and they're not in our building. And so really, I don't see what they do. And it doesn't play much of a part into my day-to-day or my coworkers' day-to-day activities. So I needed a system that I could actually be able to feed data into and to give it to, the everyday person, where they can actually go through their own metrics and go through their own data and see what's going on and make informed, good decisions. So that's part of the need we have. Also, I've already mentioned we're pretty deeply ingrained in relational databases, probably because they've been around forever. And so just finding what you're looking for a lot of times, if I'm preparing, one of my statistical factory control meetings that I go to, if I needed to go for an entitlement, which is saying, hey, my process is going to be performing here, just for one slide, it would take me 8 or 10 different data sources to be able to piece together one slide. And some of those slide sets are like 40 slides deep. So it's time intensive. And then I know what I'm doing usually when it comes to databases and be able to query my own data. That's not a typical skill set that most of my coworkers have. So the more that we can automate stuff, the more I can put the data into those tool owners' hands, or the better decisions they're going to make. So that's part of my effort here and part of the spirit of this. And also, because we're an older company, a lot of our systems are old. So I'm trying to bring us, at least in the last 10 years, relevant, hopefully. So why InfluxDB? Why am I looking at this? Well, like I said, we already have a battery of relational databases. If I want to prototype or make any applications to try to ease people's lives a little bit, then I typically have to justify it. And I have to give a return on investment to the IT group, who then wants a full architecture of whatever I'm doing and try to quantify everything and how many bits and bytes I'm going to be using. And ultimately, it could take 3-4 months for me to get any movement on it. So you really whenever you have an idea or you want to push a project forward or prototype or experiment with something, you really got to want to do it, because to be able to push something across the finish line, it's going to take you a year to justify with our current systems. It's problematic. So Influx, I was familiar with it because my daughter's on a ventilator, and she's vent dependent 24 hours. So I monitor her pulse oximeter at home. Initially, I was using it so I could actually see what her sats were at, or what her O2 percentage was from across the house. The ease of installing it was great. It took me about 5 minutes to get it up and running. I use Grafana at the house. I also use it at work, mainly because I can plug it in directly. I've worked with some of the other solutions. I played with Cabana. I played with what else? Chronograph and some of the various different things. At work right now, and like I said, at home, I use Grafana, and I'll go into my explanation is why when I start showing you some of the dashboards or some of the alerts that I'm currently using. But that's why I chose Influx, primarily because I enjoyed the fact that I don't have to plan out a relational database ahead of time. For prototyping, it's wonderful because if I don't like a measurement, well, I can drop the measurement. Or if I need to add a new measurement or add a new tag at any time, I can do so and not even skip a beat. I also like the fact that the Influx QL was already, as I said here, SQL-esque. So it wasn't I didn't have to go home and try to learn Gremlin or try to learn Cypher or one of the other query language, and I know they have Flux, but with my day-to-day activities at work, I don't have time to really delve into all that stuff. Most of it's done, I do it as a hobby, and I do it because I enjoy it. But I mean, there's a limit that I can do. So it was nice that it was already SQL. My query responses, if I'm specifically looking at time domain data, is very fast compared to some of our relational databases because, well, that's what it's optimized for. So it requires a little different thinking when I'm loading it and what kind of data I'm pushing to the database. But it's worth it, Now, is it a solution to everything? No, most definitely not. Some things a relational database are just more seasoned for attacking, but for time series, it's been great. I also enjoy the fact that there's mathematical functions already built into it. They already have some forecasting built into it for Holt winners or triple exponential smoothing. So just like I use any window function or aggregate function in SQL, I can do that with the derivative or integral. So that's very powerful because we already use some systems that we use for our tool traces or our temperature traces that, we can build logic into, similar to, what is it, to LabVIEW. But I can bring some of that functionality here just with a new command or a new function. So that's very powerful, and I'll talk about how I use some of that here in a minute. And I've already touched on the plugin for Grafana. You can obviously plug in many other data sources with Grafana. It was easy. All I had to do was point it at the actual server, and I'm up and running. So and last but not least, I'm using the OSS edition. So I'm not running distributed right now at work. I'm doing more of a proof of concept because it's still newer to me. But so the edition I'm using is free. So I don't have to quantify an ROI on something that's free. So my current setup at work, I have two VMs, both RHEL VMs. One of them is running the actual Influx instance. My other one is running my Grafana server. And then I have a Apache running on them, which I am running as a reverse proxy just so I can serve up static sites or CGIs, as well as the Grafana server. Some of the metrics I'm currently testing or collecting are OEU, which I've already spoken to. It's how much time we're actually testing good die versus our total time that we're up. Also tool availability, it's the analogous to OEU, but for the front end. So we actually use that in the fab. How much time is my tool up versus my total time? I look at occurrences in states, and I also map out, our states are mapped to a bunch of small subcategories. To who actually owns it. Is it a manufacturing state? Is it an engineering state? Is it, I was legitimately down? Are we doing a new tool install? There's just a lot of mapping that's involved that gets confusing. So I'm actually bringing all that into one report, just so I'm able to actually forecast on that, kind of break down the data, which I'll delve into in a little bit. I'm also starting to collect cycle time, and also time between failure and time to recover. I've started to add that data recently, which I haven't updated the slide. So it's just a block diagram of essentially what we're doing. I have a bunch of loader scripts, primarily written in Python. I don't have any R on the server, but yeah, primarily I use Python and R, or what I use on a day-to-day basis. So I use the InfluxDB client to actually push the data that I'm extracting from our relational databases into my Influx instance. So it's pretty simple layout, easy to follow. So going into some of the examples of what I'm doing. Now, this is my overall equipment utilization for the group I'm currently in right now. I keep this open just to see, well, how are we doing today? Now, most of the time this is calculated, or has been in the past, it's aggregated by a month. I think the smallest time window I could get it at for this specific metric before was per hour. Now I'm actually capturing it every minute currently. And I haven't gone through all my retention policies and how long I'm still kind of working out the broad strokes, because really I've only had it installed since late November, early December. 1 minute for a long-term duration, I'm not going to need that. I'm eventually going to downsample and to let the data fall off. I haven't, with COVID and everything else going on in the world, it's been difficult to work with people because a lot of people are working remotely. So any meetings that we would get together to actually sit down and discuss stuff like that, it's been kind of put by the wayside for the time being. But what you're looking at is the green trace is our OEU per minute. Now, I also have a dashboard that breaks it down by tool set and by tool, that shows me how those specific tools that are making up our overall metric, how they're performing over time in a longitudinal form. The yellow is our current goal. So that's what we're actually, hey, we're in the green in a meeting if we're reporting out. If our aggregate for 1 month is above that yellow line. The blue, I was just playing with smoothing it. Now that's actually being averaged over an hour. But I'm taking this just to pretty much start let me back up a little bit. So I'm collecting this data, A, because we get judged over it, and then we use that to say, hey, we're doing good or we're doing bad, essentially. Now, what I wanted to capture it at such higher rate for us at 1 minute, mainly because since I'm on the manufacturing side now, I want to see kind of what our operations are, and to be able to deconstruct that to hopefully understand behaviors and human behaviors. And that may sound a little creepy, but I honest to God think that I can show seasonality in our metrics because I know they exist, because we're all such creatures of habit. And most of the people that work on my team have been doing it for 30 years, that the chances are that I can understand a lot of what they're doing just by breaking this apart, looking at seasonality, looking at our trend, and kind of delving a little deeper. And it seems like this is kind of newer to me. But in the past, usually I'm in a meeting and someone's like, oh, okay, I'm showing for the last year what I look like every month, how my metrics are doing. And really all it tells me is, yeah, I did well last month. I'm kind of on a slight upward trend because I'm a little higher from the month before, and this is what I need to try to get better. But apart from that, I don't really get any more understanding on that, using that metric or what I'm doing. or why I'm performing the way I'm performing. You know, I've always got to drill down deeper and deeper. But I think the kind of cool stuff about all this is that just using that data, I can break it apart a little more and go a little deeper without having to break out 30 different reports and drill into it. This is just kind of an example. I didn't do any transformations on the data at all. I wanted to try to prove the seasonality and what's going on across our shifts. We run 4 shifts. I came in the group, like I said, not late September or early October. And part of what I was told is that one half of the week performs like this, one half of the week performs like that. A lot of it's learned behaviors. A lot of it's the way we park our tools in certain states, or perhaps a standing order from a supervisor saying, hey, you're going to idle this set of tools, especially right now with everything going on, just to focus all your efforts over here on the other side of the floor. Now, whether that's right, whether that's a wrong call to make, I don't know. All I know is we do perform differently across shift, and part of this is an effort to understand why we are and what we can do to try to improve that. So what I'm showing you now is the same data I captured here, but I've used, in this case, I was using Facebook's profit package just to kind of break it down to what I'm interested in. How does it look across the week? How does this line up with how our shifts perform? What type of, you know, what type of contribution are they making to our overall trend? What does the day look like? Are we putting up tools first thing in the morning, or are we sitting down checking emails for 2 hours before we get out to the floor to actually do stuff? So a lot of this is just in the efforts to try to understand our human behaviors and how we can try to close those gaps and get best practice across all of our shifts, you know. And so I was able to confirm some of our beliefs with this. Now, obviously, our next step is to drill in deeper to see, well, is this do we have a staffing issue? Are we doing something with states that we shouldn't be doing? Are we idling tool sets that are constraining the rest of our floor? That's the next question that comes from this. And let me go. Okay, another thing, I'd mentioned it earlier, some systemic problems perhaps happening on the floor. I don't necessarily care if my metric here is dipping down below our goal for 5 seconds or for 2 hours for that matter. It doesn't really matter to me. What matters to me is something like this, where it looks like it's crossing off, or it's falling off a cliff. Now, this is representative of our whole test floor, so obviously there's probably something systemic that was happening. So I actually used Influx's derivative for its rate of change. And my main interest was say, okay, I don't care if you're dropping for a momentary point in time. I want to know if you're dropping quickly across everything over a short duration of time. Now, with Grafana, I could easily do that and set up an alert rule, and I was able to actually receive this email. And this instance that I'm showing you has happened in the last month or two, where we actually, what our systems were failing to write to a database. So it was actually locking up our tools. Now, IT is the one that has the keys to the kingdom to be able to go in there and fix that. But this allows us to see that at 4 in the morning, that we did legitimately have a problem, and then we were able to go and address that with IT and get our tools back up quickly. But we do have bells and whistles and alarms on other systems. This is real time. This is something that I can see and dig into it. And it, like I said, it took me a very small amount of time to set up. I did not need to be a full stack developer to be able to get this up and running. So this is just another example of some of what we're capturing. I went into the states. I've actually broadened this out since I made this slide set, so it actually breaks it down into what we call our E10 states or E10 distributions. So all of these are mapped into, like I said, we had 515 overall states. They get, I'm showing you the breakdown of states, how we're doing it, or what we're currently at, and then I show the E10 distribution, which is it an engineering state? Is it currently in production? Is it a scheduled down state? Is it a non-scheduled state, standby state, or unscheduled down state? So pretty much all these 515 states can be narrowed down into these groups for most of our calculations. So this is in an effort to understand where our states that we're spending time in, what's taking up most of our time, and then how that actually breaks down into what we use for our calculations here in E10 groups. So I pay attention to this to see what tools are up, active in production at that point in time. I keep this as well as my other one open because I don't want to try to run queries all day to see where we're currently at. So obviously, if all of a sudden we have 2 tools in production, well, I need to go respond real time to the floor and see, well, what are our technicians doing? What are our specialists doing? Are we taking 5 lunches? What are we doing? What's going on? Or do we have something, a larger problem that we need to deal with and deal with quickly? This is just another example. I'm also capturing it in the fab. So I'm helping some of the managers on the front end of the line. This just shows how I'm actually breaking it down by our different processes and tools. And then you can see the traces obviously there. Now, my intention is to eventually be able to use some of this data to not only for real time, but to help plan for, well, last year we had 50% staffing for Christmas. Do we need 60% this year? Is it all right if I let 1 other person off or 2 other people off? Is that all right? So they can go spend time with their family. And then also, can I predict whether we have enough tooling available when we hit a certain device mix on the floor? So all these are questions that, we can take stabs at, or we can take, we can do a weighted moving average, and I can give you some point. Or if I have the data that I'm already collecting that I need to report out about, that's temporal, can I use that to actually make a better prediction with a confidence interval on it? So that's pretty much the direction I'm trying to move in that. Some of the issues I encountered when I was in spinning up the InfluxDB instance on our VM, this is probably has to do with our proxy settings at work, but I couldn't write data initially to I couldn't push the data to the Influx instance, and it turns out it was my proxy settings that I had set for Python that were keeping me from doing so. So I pretty much just had to comment these out of my runcom file I was sourcing, and I was good to go. Another oddity was using the derivative function. I've used plenty of window and aggregate functions in SQL. In my particular use case that I was using, I had to specify a where clause. It didn't take me very long to figure out that I needed to do that, but it was something I wasn't expecting getting an error from. So that was a small hiccup. Another thing that usually eats my lunch when I'm dealing with time series stuff are timestamps. What's the server timestamp? What's our database timestamp? What's our local timestamp? And then, understanding what I'm pushing to the database. Of course, initially when I was using Influx assumes everything's going to be in UTC time. So if I'm writing anything from American Chicago time zone, well, it's either 5 or 6 hours off. So it's just something I have to be careful about. I probably, when I'm introducing more people to this system, I need to I need to write some documentation on our timestamps and what's actually being collected in our time series. And that way, if I'm handling it by pulling data out to do analysis, that they'll understand what they're getting, and they're not getting zonal data, they're getting, GMT or UTC time. But anyway, that's more of my issue with time-based data, and part of the not necessarily the software itself. A last thing I really kind of miss and wish that was available was I see some of the primitives, at least that are available for grouping in Influx, or you can do it by a minute, by a day, by a second. I have 30 days that I can group by, but I don't have a month primitive to, if I want to pull and aggregate by a month, I don't have that readily available. Flux has that apparently. Again, I haven't learned Flux yet. I haven't taken the time to do that. I'm still using InfluxQL to pull data. I could add a month tag, which would make it easy, but then of course that's going to utilize more memory. But that's something I need to explore more, especially if I want to break stuff down by month, which I often do. And part of the nicety of the time series is I have so many edge cases if I'm trying to aggregate metrics across months. So if a tool went down at the end of last month, but came up 2 days into the new month, how do you split out that time? And then not just how do I split out that time or divvy up that time, but how are the systems that I'm getting judged by currently that we're using on an enterprise level, how do they really handle it? And what assumptions are they making? So I think the fact that I'm sampling at 1 minute for my immediate metrics, that I'm able to handle most of that stuff inherently, and I don't have to worry about actually splitting up that minute across 2 different months. So what's next? I'm trying to, I said something earlier about having to go to 8 different data sources to pair one slide. It's like that for pretty much a lot of our systems. We have some enterprise solutions that, in my opinion, are kind of clunky. A lot of our older stuff is written in Perl or some other framework that's probably 20 years old. It's lacking some capabilities. We can't group by certain tool sets, or I can look at one trace and see how I've been doing historically, but I can't bring in everything else, to see, well, how does that stack up with the rest of my tools? Where's my, what's really affecting my metrics? So just for the fact that most engineers, at least that I've, been in contact with and I work with, we all have the same problem. We've got all this data and we've got to try to, as efficiently and fast as possible, try to sum it up and figure out what's really going on with my tools and my processes. So a lot of the higher level metrics are all temporal. So I'm going to be trying to wrap up most of our tool and process capabilities all together into one single. I'm saying dash app because I don't have a node framework or node to work with. I have WSGI modules. So, and I use Python regularly. So I'll probably be trying to spin up a dash application that tries to encapsulate all of that into one-stop shopping. So that way we can spend more money actually, or more time, excuse me, going out and solving some real problems instead of trying to figure out what the problem is. Now, for me personally, I've been reading a lot of books trying to dig into this more. It's interesting to me. Instead of taking some best guess in a meeting when I'm asked by a section manager, well, how do you think you're going to be doing next month? Or, is that action that you're going to take going to be effective? And if so, by how much? I see a lot of hand waving and, well, I think it's going to be good. But the interesting part of the time series is that a lot of this stuff I can put a legitimate confidence interval around, and I can give you a 95% confidence that, hey, I think I'll be at 85% most likely next month, and my upper and lower confidence interval is this. And I just think methodically and, for what we're doing, that's the right answer to trying to forecast and see where I'm going to be a month from now. So obviously there's a lot of stuff that goes into that. I've been reading a lot on ARIMA, SARIMA, the whole winners, which comes inbuilt with Influx or triple exponential smoothing. Facebook profit, I need to understand a lot more about it. They use I guess a generalized additive model. So I've been trying to dig into that more, just because I know once I open up that can of worms, then management's going to be asking me, well, how do I know this is right? How do I know the model's right? And yada, 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 yada. So I'll probably need a lot more in my arsenal to explain the math behind it, which I'm working on. But that's the general direction I'm working towards. I've already mentioned I'm starting to push the time to repair and time between failure into the time series. Again, these are pretty, I think they're exponentially distributed random variables, and they're pretty well understood. We typically look at them aggregated across a month, but I think if I'm trying to improve behaviors or how we're actually operating and doing stuff and trying to understand that, breaking it down to smaller subsections and a higher resolution is going to give me some insight into that behavior. But apart from that, I've already been kind of pitching to people time series. We use a time series. I don't know what our big data team uses, and it's probably pretty old because it's been around for a while. But a lot of people don't understand that we even push our data into a time series. But in this case, yeah, I'm starting to pitch and educate people some on further analysis that we can actually perform looking at longitudinal data versus cross-sectional data. So I think that's pretty much it. It's time for questions. Again, I thank everyone for tuning in, and let me know if you have any questions, and I hope I was clear enough.
All right, so we have gotten some questions in, but there is plenty of time now for questions. So if you do have one, just go ahead and use your GoToWebinar control panel and submit it. And let's go ahead and dive right on in. First question, are you using MemSQL to do your queries?
No, I am not. MemQL? No, I'm not. I'm using InfluxQL for my influx queries, and then typically I use just standard, what is it, ANSI SQL for Oracle. So no, I don't. I've never used MemQL.
Okay. All right, great. Next question here. Ion implant versus diffusion is different. So how do you normalize both processes in time series data?
Typically, so yes, they are different. One of them, you're delivering a, some dopant species through an E field and bending it with some B fields to implant it. The other, yes, we're attacking pretty much the whole substrate with, say, a phosphorus. Now, as far as normalizing, we normalize in our fab on our cost using photo patterns. Now, as far as on a tool basis for, say, a fail event, we're looking at how many wafers we actually move through a specific tool at a given time. We typically normalize to 10,000 wafer moves through a tool and use that to actually look at our fail events. So really what I would be capturing, and I'm not doing this right now in the time series, is our raw fail events. And then I would be able to normalize that versus our moves. And then I can compare it from diffusion versus my diffusion furnace versus an implanter. So I don't know if that answered the question, but that's how we normalize it. And in a time series, I would probably be capturing just the raw fail events and the time they occurred.
All right. Excellent. Okay, guys, just a reminder, there's plenty of time for questions. So if you have one, go ahead and use your GoToWebinar control panel and submit it. Next question here, how much data do you collect throughout the wafer process, which can last more than 30 days?
We capture everything from obviously timestamps of when things occurred to what our measurements were, whether they be a film thickness measurement or a CD measurement for a photolithography. There's copious amounts of data. I don't even know how to quantify it. I've heard the big data team one time saying that at least in one of the fabs, they're doing upwards of over 50 million points a day. And that's just looking at our tools. So that has nothing to do with our transactional data that we're doing on, where we're actually logging wafers through the line from start to finish. Yeah, there's a lot.
Sounds like. All right, great. Next question here. Are you using more than one server to collect the data? If yes, how do you time sync the data sequence?
Most of the data, I'm going to call it scraping, because I'm actually pulling from one of our sources that we have a DBA team around, and I'm doing the transformations or calculations or aggregations to what I want or my need, and then pushing it. Now, as far as the time series I'm writing to, I have one instance. I'm running the open source. I'm not running the enterprise, so I'm not running a distributed system. Now, as far as our overall databases that I'm pulling from, we have tons of them. I don't even know all of them. So we have a team that specifically deals with the maintenance of our Oracle databases. As far as the time series, like I said, for my specific case, I only have one right now, and it's relatively newer. So yeah, it's not much maintenance on one of them. So
All
it's
right.
not hard to, I'm not running across a time sync issue right now, at least not that I know of, nothing that's been startling or caused any issues.
Okay. All right, great. Next question here. What type of source load to InfluxDB? Is it .txt file or another type?
No, I'm writing a JSON document objects or whatever using Influx. I pretty much just package up a payload. So I'm using pandas typically in some cron job to just kind of get the data frame set right, and then I iterate through it to package into JSON and then push it off that way using the Influx client. So I know they have a lot of other clients you could use. I've used it in R before to push to Influx. I don't do that at TI. I do that at home. And then I don't know Go or some of the other languages that you could use or they have clients for. But right now I'm just using Python to load into JSON object to push it off.
Excellent. All right. Okay, guys, as I said before, plenty of time for questions. So if you have one, please go ahead and use that GoToWebinar control panel. Our next question here, are you using weights in your models to describe, for example, a more complicated product?
Yeah, I'm starting to experiment with bringing in exogenous variables. So I'm capturing how many people we actually have at work, on the floor at a given time, to be able to use that to tune the models more. I haven't actually done that yet. I've just started capturing the data on that. I'm also looking at what device mixes we have, how many we have on a given month or a given day or a given time on the floor. Because obviously some of our devices, in our case, it could take anywhere from, I could test away for an hour or I could test away for every 4 days. It depends on what kind of test you're actually running and performing. Am I running a lot of, am I looking at slew rate and frequencies and, I mean, the list could go on. And we run some 3.5 stuff also, which is not silicon. So it's more R&D stuff where you end up, we do test maybe away for every 6 hours instead of, multiple ones within an hour. So I'm starting to look at the time accrued doing that, or the cycle time through a specific log point or tester. I'm capturing that, and I do plan on using that to tune the models more. Now, I haven't actually done that yet, so I can't tell you what that looks like or what issues I've had. But I know you can do it, so I've started capturing the data.
Excellent. Okay. All right, so we're about 7 minutes to the top of the hour. So I think we have time for one or two more questions here. Let's see, what data visualization tools are you using? Splunk or Python or something different?
Well, no, typically, well, right now, like I said, for real time, I'm using Grafana. I use Plotly Dash a lot. I use Plotly with R also. I've done some stuff with not usually D3 if I'm doing any web stuff. I wish I knew D3, but I think I would need to study it for quite a while. So I use a lot of like I've used Dimple and like I said, Plotly. That I think a lot of that runs, especially in web-based with D3 under the hood. But yeah, I use ggplots and R a lot. Matplotlib if I'm doing anything static. Obviously if I want to make it interactive, yeah, I usually use Plotly or Plotly Express now to try to spin up something interactive. And a lot of times that's useful because if I'm working with someone where I have to take a bunch of slices of the data, say a time frame or a frequency range, that I can really now just wrap it up in a Plotly object and generate HTML and then send it to someone so they can actually kind of dig through the data themselves, or at least that data set. So that's what I'm doing now. And then for real time, I'm using Grafana, obviously.
Okay. All right, great. Next question. Can InfluxDB send alerts, or do you rely on something else like Nagios?
I know
to send
Influx
alerts?
can if you're running the full tick stack. I believe
Yeah.
Capacitor if you write a tick script. you can do it. I'm not doing that currently. I started to experiment with Telegraph at home since I'm already running an Influx instance just to see what it does and if they had any plugins that would be useful for me without writing my own. Since I'm not using that, I am using the Grafana alerts right now.
Mm-hmm.
And most of that's based on some mathematical calculation or limit.
Okay.
So, yeah.
All right, great. Well, so we're about 5 minutes to the top of the hour. So unfortunately, that is all the time that we have for the question and answer period. But I do want to thank everybody who did submit questions. We had some really great ones today. I'm actually pretty impressed by the level of the questions that came in. So thanks, guys. I really do appreciate it. Also want to remind the audience real quick that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on demand section, and it should be right there waiting for you. Alrighty then, so at the top of the hour, I did mention that we would be doing a drawing for 6 $25 Amazon gift cards. So without further ado, let's go ahead and get that done for us. All right, today's winners are Juan P. Congratulations, Juan. Our next winner is Marvin W. Congratulations, Marvin. Our third winner today is Rachel T. Congratulations, Rachel. Fourth winner is Sid B. Congratulations, Sid. Fifth winner is Alan D. Congratulations, Alan. And our final winner for today is Frank J. Congratulations. So we will be following up with all of you card over to you. So please check your inbox or check your, I guess your spam folder if for some reason it doesn't show up in your inbox. Okay, so Mike, thanks so much for such a great presentation. Lots of really interesting stuff. It's a bit of a departure from what we normally have on the webinars, but good content. Loved hearing about it. Thanks so much for your
Thank you.
for your expertise and your time. So also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody. Please stay safe.